The rule to integrate polynomial is the reverse of the of the differentiation. So for example, if you used to have f to x and you would like to differentiate it, f to x equal ax to the power of n. To differentiate, you multiply the constant by the old power, and then you take away from the power. And the integration is the opposite. So for the integration, if we start with f dash to x equal ax to the power of n, so you notice you're integrating, so the differentiation is given to you. Then f to x is equal integration, like a long s, that's the integration sign. We don't have that. And to f dash to x with respect to x, meaning I'm integrating with respect to x. So if you are integrating ax to the power of n with respect to x, the answer for the integration is constant stays the same. You're adding 1 to the power and you divide by the new power. So adding 1 to the power, divide by the new power. Here you're taking 1 from the power, you multiply by the old power. And once we've integrated, you remove the sign here, and then it's plus c. Because if the original function has a constant, when you differentiate, the constant is 0. So therefore, there is no sign of the constants in the differentiation function. Let's take some examples. So this one here, we're integrating, so we're adding 1 to the power, divide by the new power, minus to the power, adding 1 to the power, divide by the new power, minus the integration of a constant is 3x plus c. You can simplify or easier leave it as it is. The next one, there is no product rule for the integration sign, for integration. So therefore you will have to expand first. So we need to prepare our expression for the integration first. So we keep the integration sign and we expand and simplify. So we have 15x squared minus x plus 20x minus 4 with respect to dx. Then I would expand and simplify first. Plus 17x minus 4 dx. Now my expression is ready to be integrated. 3 plus 17x squared over 2 minus 4x plus c, and you can simplify. So I've got 5x to the power of 2, 15 over 2x squared minus 4x plus c. Right. Now you can stop up to that third line in here. You can stop here if you want, if you don't need further simplifying it, because if the question was just integrate, so you don't need to simplify further. But if you need to substitute later or solve something, then it's better to simplify. We've got here the power. Again, it's a polynomial. The power is in the denominator, so we use the same skills as we use in the differentiation. We move the expression or the x expression that has power to the numerator to prepare our expression. I don't know why this dot is coming in here. So it's 5x to the power of -3 plus, you cannot integrate when it is in the denominator, the x value, the x power. Okay, now you can integrate normally. So fx adding 1 to the power of -2 divided by the new power, x -6 adding 1 to the power divided by the new power plus 6. You can simplify, rewrite it as a positive power. That's negative. Right. Okay, so we have a third expression. So we need to change it from a third format into index format first. fractional format, and then we integrate. So we need to prepare our expression for integration first. That's 6 x to the power of 3 over 4 dx. Then we integrate normally. So remember, once we integrate, we don't write that sign of integration anymore. We can so that's 4 over 7x to the power of 7 over 4 plus c. Sorry, that's a mistake. That should not be dx, it should be plus c, because we've integrated. Those are the final answer. Then you can rewrite this as an index format, as a surd format, plus c. So this one we have surd format, and also the surd is in the denominator. So we need to do 2 steps to prepare our expression for integration. So the first step is rewriting it. And then the next step is moving the index into the numerator, and you notice that I'm writing my integration sign because I haven't integrated anything yet. And now my expression is ready to be integrated. The 8 over 3 is a constant, so I'm not going to play anything with it. This one will be x to the power of negative 6 over 5 plus 1 is negative 1 over 5 over simplify even further, that gives me negative 40 over 3, and then because it's negative power, so I'm moving the x to the denominator to change it to a positive power, and then rewriting it as an index format. This one here is a surd format, plus there is a multiple, it's a rational expression. So it's a rational expression is very important. We need to see which can we split fractions and simplify it, because we only have one x at the bottom, at the denominator. Therefore you can split fractions, simplify, then you integrate, because there is no quotient rule in the integration. So the first step is we're going to split fraction. While I'm splitting the fraction, I'm going to rewrite it as an index format at the same time. So I'll do 5 x to the power of half over 2 x to the power of 1/3 plus 7 x to the power of 4 over 3 over 2 and x to the power of 1/3 dx. Then I can simplify the fractions at the powers. When you divide, you minus powers. So I have 5 over 2. So it's x to the power of 1 out of 6 plus 7 over 2. X to the power is 4 over 3 minus 1 over 3. It's 1. dx. So we still have not integrated, therefore we keep the integration sign. So now we're going to integrate. So it's 5 over 2 x to the power of 1 over 6 plus 1. It's give me 7 over 6 over 7 over 6 plus 7 over 2 and x squared over 2 plus c. You can simplify further. So simplifying the expression, 5 over 2 divided by 7 over 6 is 15 over 7. And you can rewrite this expression as a surd format. So it will be x to the power of 7 in the 6th root plus 7 over 2 and 7 over 4 x squared plus c. So far what we've done, we've integrated and we added plus c, but to get the final expression we need to find the value of c itself. So therefore you need to have another information given to you in the questions. So in here we've been giving the double differentiation function, and then we've given the value of f, and then you want to find the fx. So the first thing, we're doing an integration paper, so we'll integrate to get to f to x. So we'll integrate first, and that give me f dash to x. with respect to x. So f dash to x, again we prepare our expression for integration. Negative 2 divided by x to the power of -2 over -2 plus x plus c. And then simplify this. Very important that we simplify this one. So we got 1 over x squared negative plus x plus c. Now we're going to integrate this again to get f of x. Right, so now we can simplify as much as we can, and that gives me 1 over x plus x squared over 2 plus cx plus k. Now we're going to use those two pieces of information to find the c and the k, because we have two unknowns, so we need to find we need to have two simultaneous equations to find two unknowns. So this one means we substitute the x instead of the x1, and the answer is a half. So f to x is equal to half and is equal to 1 over 1 plus 1 squared over 2 plus c plus k. And simplifying, and that will give me 1.5 plus c plus k. Rearrange, taking the 1.5 to the other side, give me -1 equals c plus k. That's my first equation. Now my second equation is the same, so we have 6.5 equal, substitute 2, so we will have 1 over 2 plus 2 squared is 4, 4 over 2 is 2, so that's 2 in here, plus 2c plus k. And then simplifying this gives me 2.5. Take it to the other side. So 6.5 minus 2.5 is 4. Equal 2c plus k. That's c. Okay, now you can use the graphic calculator to find the c value and the k value. So remember, in the graphic calculator, you go to menu, equations, and simultaneous, and then you're going to enter the values for the first one. So 1, 1, -1, and for the first one will be 2, 1, and 4. So c is 5, and k is -6. Therefore, my f to x, you must write this last expression. So my f to x is 1 over x plus x squared plus 2 plus 5x minus 6. So you must write this last statement because the question is find f to x.